Hello everyone, good evening. Today I will be discussing daily lead code challenge. Today's lead code challenge question is find the maximum length of valid subsequence one. So in this you will be given one array in which you have to find the maximum valid subsequence with the given condition. So let us discuss the problem first. Let me explain you the problem first. So in this question, we are given an array of size, size n. Let's say you are given some array and two, three, any number of in array or in numbers are given in the array. So you have to calculate the maximum length subsequence with the following rule. If the subsequence, let's say, sub some length subsequence is available, you have got this subsequence as the answer. So consecutive elements in sum of the mod of the sum modulus of the sum of the consecutive elements in the subsequence should be equal. So let's say we are taking 2, 7, 8, 7. So this is the where is initially I'm not checking it is the longest or so we have to find the longest subsequence. So I have taken this subsequence for example. So in this example, if I take the consecutive number modulus, sum of the consecutive number modulus with 2 is equals to 1 and 7 plus 8% 2 is equals to 1, 8 plus 7% is equals to 2 is equals to 1. So if we take two consecutive numbers, sum of modulus of the sum of the two consecutive number, it will be equal to 1. Okay. So all the consecutive, the modulus of these consecutive pairs is equals to 1. So this is our task actually. We have to find such a subsequence that is the longest in the length and have modulus same for the every consecutive pair. So this was a valid subsequence, but whether it is the longest or not, we can try checking another one. Let's say we have taken this two, three, oh, complete subsequence. So complete array, if I consider the whole array as a subsequence, a valid subsequence, in that case, the modulus of these two, one first pair is 1, second pair is 0, third pair is 1, fourth pair is 1. So this pair cannot be included in this longer one because the modulus of these two is 0 and others modulus is 1. So it was the sequence we chosen was a valid subsequence and actually the optimum subsequence that is longest that follows the property we lost. So to solve this question, one thing I have we have to check here, like the property of modulus operator. Modulus P is equals to proper plus Y modulus P. So X plus Y modulus P will be similar to Modulus of x and y modulus individually. So, for example, if we take 2 and 3 here, 2 plus 3 modulus 2 is equals to 1, and modulus of 2 is 0, modulus of 3 is 1, 1 plus 0 is 1, modulus 2 is equals to 1. Another case, let's take some even number. 4 plus 8 percent 2 is equals to 0, while 4% 2 was 8% 2% 2 is equals to 0, because 4 minus 2 is equals to 0, minus 2 is equals to 0, minus 2 is 0. Let's take two even odd number. It is also 0, and if we take individual value modulus, is 1% 2% 2 modulus 2 is equals to 0. So in this way, this property will be um, valid prop means this property holds for the modulus operator. So either we take modulus of some of these number, or we take the modulus of mo some of the individual modulus of the numbers will be equal. So as p is equals to 2, so here modulus values only can be 0 or 1. So if we convert this 0 array to 0 and 1, in that case, we will we can easily prepare the pairs of this. So let's convert this array to the value with the individual modulus. 2's modulus is 0, 3's modulus is 1, 7's modulus is 1, 8's modulus is 0, 7 modulus is 1. So this array is converted to this array after dividing the modulus by 2. So in this case, even if we take the modulus of pair of some of the pairs of this array, it will be answer will be similar for this, means like some subsequence, means on there will be no change in the answer. Even if we solving this array, it adds same as solving this array. So we can easily solve this array. So let me erase first one part of this page. Mm, So we have got this array now. 10101. So we have to find a largest subsequence in which consecutive pairs, some of the consecutive values modulus should be equal to 1. So if we check here, there is two possibilities, actually three possibilities in which this condition can be true. Either it is the consecutive numbers are 1 plus 1% to 2 is equals to 0, or they both are 0%, 2 is equals to 0, or 1 plus 0%, 2 is equals to 1. So there can be three conditions only. So if there are consecutive ones, their modulus is also same. If there are consecutive zero, their modulus will also be same, and their modulus will be 0. If there are alternate 0 and 1, 0 and 0, 1, 0, 1, 0, 1, their modulus means consecutive pairs modulus will be 1. So let's consider this by example. Let's say we find a subsequence that is looking like this: 1, 1, 1, 1, 1. If we take modulus of any pair, consecutive pair in this array, in this subsequence, all modulus is 0, right? All pairs modulus is sum of all pair values is 0. Similarly, if we take 0, 0, 0, 0, their modulus will also be 0. But one thing to consider here, we cannot take a subsequence like this. We have some consecutive ones and then some consecutive zero. In that case, this cannot be answer, because in that case, for pair of ones, the modulus will be 0. For pairs of 0 also modulus will be 0. But there is one bound transition point where modulus is 1, that is not equal to 0. So this type of subsequence is not possible actually. So either it should be a consecutive ones or it should be a consecutive 0, right? So another case can be if the consecutive pairs modulus is 1 only, like if we consider a subsequence 0, 1, 0, 1, 0, 1. So every consecutive pair is every consecutive pair's modulus is 0. 1, sorry, that is 1. So we have to find actually check these three cases only, and that will be the answer for us. So we'll count 1 or 0 and 0. If results will be initial result will be equal to the maximum of these two. Which one is the maximum? The answer will be 2. So if we consider in this count of 1 and count of 0, count of 1 is 3, count of 0 is 0. So consecutive 1 can be possible or 3. So the intermediate result will be 3, size of 3. And now if we consider alternate ones, 0 and 1, 0, 1, 1, 0, 1. So there are four numbers are coming here. So the result is really 4. So what we initially checked here, that the value of the subsequence was only 2, 3, 8, and 7. In this way, this problem can be solved easily. So let's check the solution once. So I have already solved it. So initially, I have updated the array with its modulus value, individual elements modulus value by 2, modulus by 2. So, and I have been, I at the same time, I keep counting the zero values in the array after the modulus. So the initial result, I am considering, I am initializing result to the number of ones here. Means the CNT result represent the number of zeros in this array, and total length of the array is the num slot size. So the result at this point contains the number of ones. So I update if the number of zeros is greater than number of ones, I update the result to number of zeros, and otherwise result will be itself one, number of ones. So now the second, actually the first uh, con- uh, two situations are handled here. Now I have to count a alternate 0 as 1. If they are in larger in number, the result will be updated to the means the count, net count, means the alternate count, intermediate and count. So it is a simple check. I have initialized the current value to first value in the nums array, and I keep checking if current is not equal to nums. I create the count and update the current number. If at the end, if the CNT is greater than result, it will be update the count and I will return the result. So let's see, take the code uh, by submitting it. It is passing 100% test cases. There are, it is not at 100%, but I think it's a straightforward solution, so that is okay. Okay, thank you, guys. Hopefully, you enjoy this video and let's meet next day. Thank you.